Hello everyone. Today we'll be discussing about Introduction to Well Logging Part 1. In this we'll be discussing about the lithological parameters, fluid parameters and the factors that affect the logging. So here you are seeing a wide range of loggers, resistivity logger, spot loggers, continuous logger and then gamma caliper logger. In the coming lessons we will be discussing about all these loggers and the parameters in detail. So I'm just giving you an introduction now. We are actually using the geophysical well logs to determine the lithology of a well, geometry, resistivity, and formation factors, and also other properties like the bulk density, porosity, and permeability of a formation, the amount of the moisture content in the well, and also the specific yield of water-bearing rocks. We are only discussing about the hydrological logging, not the oil and gas logging. So everything is related to the groundwater only. Later on, you can correlate the same with the oil and gas also with little changes. So the geophysical logging are also used in determining the source of water content and its movement in the well and also the chemical and physical characteristics of the groundwater. So let us first understand what is a well log. So well log is a record of a sequential data of any well. See if you can see this is a well and we had a gamma logging and we got the record in the resistivity and the neutron for porosity and bulk density. So this is actually a well and the instrument is sent into the well and then you got the record. So we call this particular paper or the sheet as log and the graph is like a sequential data record. So this can be used in the water or in oil and gas also. In general, geophysical logging is also called as borehole geophysics because this is including the study of all techniques. Now, what we do is we lower the probe into the borehole and then we record parameters like characteristics of the rock, fluid that is in the rocks, and also the construction of the well, that means the diameter of the well and all. And why do we need a bore well log? When it comes to finding the subsurface features or the properties, we generally go for the surface resistivity meters or surface techniques. But in the subsurface, if we want to know the information, we need to drill the hole and then see. But this is also an expensive thing. So if you are doing a log or a geophysical well logging in the existing well, you can get the information. And the same way, if you are doing the well logging in different locations, then you will have different parameters, and that will be very easy to identify the or correlate the lithology or the geological parameters in a particular area. Okay. So before conducting any kind of geophysical well logging, we need to have proper planning and we need to have different things to be noted. So first thing is we should understand why we need to do the logging. See if we are looking for the in availability of any kind of radioactive material, you go for the gamma ray logging, and you want to know the porosity or any other features, you can go for the gamma ray logging, and to find the resistivity, go for the resistivity log, and like that. So you should understand why you need to log and which type of log you want. So if you take an example, so I'll explain you here. If you are looking for the lithology and stratigraphic correlation, then we go for the electrical log and also the nuclear logs. And if you want to know the porosity or the bulk density, then we'll go for the sonic logs or gamma logs or the neutron logs also. And to find the effective porosity, we go for the normal resistivity logs. And to find the shale or clay content, we go for the gamma logs. To find the permeability, we can go for the porosity log or the sonic log, and to locate the water level, then we go for the electrical log or temperature logs, and in that you have many different kinds of logs. So based on that you will be finding the method, and then once you're confirmed with the particular drilling and all, then you have to see that the drilling operation hole that is being drilled is completely like uniform. See here you can see the lithology, and this is all of different layers. So if you want to have a particular clear data, you need to have a uniform well like this, something like a symmetrical well which is having very less deviation. Then you'll get the proper information from top to bottom. So in this well logging, we'll be discussing about many factors or the parameters, just like I told you before. So the first parameter is lithology. So in general, the most characteristics of a rock, the fluid they contain, and the borehole may have effect on this response. So based on the fluid and the lithology, the values will change in the log. And when it comes to the resistivity, that is the second parameter, you can see the SP value and the short normal, long normal resistivity values. So the electrical resistivity of a rock, see you have rocks here like this. So the electrical resistivity of rock will depend on the physical property of the rock and also the type of fluid that is present inside the rock. So most of the sedimentary rocks contain particles with high resistance, which will oppose the flow of the current. When these rocks are again saturated or they become wet with some kind of water or any kind of liquid, then they become wet and their spore spaces of the rock will be relatively conductive. Okay. So when we say that the resistivity of a rock is a function of the amount of fluid that is contained in the pore spaces of the rock and also the salinity of the rock. See here, if you see brine, this is like a saline water. The main factor in pore geometry is defined as the square of the ratio of the current to the length of the sample through which it flows. So these are the two parameters now, lithology and resistivity. We'll go in deep in the later sessions, and we'll go for the next parameter, that is permeability and porosity also. So permeability, we know it is a important lithological parameter, and we have two types again. Intrinsic permeability is like a mean of the relative is with a porous medium that can transmit a liquid under a potential gradient. The hydraulic conductivity is the quantity of water that will flow through a unit cross section of area per unit time at a specified temperature under hydraulic gradient. So to derive the permeability value from any log, we must first remember that it is not only related to the porosity, but is also related to the grain size. So here you have a small grain size, you have a big grain size, and you have different grain size here. And also their orientation. See here there are completely in a different orientation. Here you have different orientation, and also the type of the cementation between these grains. And the same way we can also take the porosity as the next parameter. In general, porosity is derived from the gamma gamma logs or the neutron logs and also the electric logs. So in any of these, you will get the porosity values mostly. So permeability and porosity are related to each other based on the amount of water that is stored in the rocks. So we consider porosity as an important hydrological factor. Porosity is simply defined as the ratio of the volume of a porous medium to the total volume, and this is generally expressed as a percentage. So the total porosity includes all the pore spaces in the channel or in the material, irrespective of whether they are connected or not. Effective porosity means only the pore spaces that are interconnected and effective in transmitting the fluids. So total porosity doesn't require any kind of connection between the pores, but effective porosity wants or it needs the interconnection and also the transmitting fluids effectivity. So in most of the sedimentary rock, effective are sandstone and sand and all. So they are like more effective, and then they have good porosity and permeability also. Though the unconnected pore spaces are filled with water, they do not hold the resistivity because they are not connected to each other. So when you do an electrical log, you don't find any big changes. Whereas water filled in the connected spaces will impact the resistivity because here you have added water and it is traveling from here to this, and then you'll have a different impact on resistivity also. So again, porosity is divided into two, that is primary porosity and the secondary porosity. Primary porosity is actually a characteristic of a rock, which is related to the original size and shape of the grains, and this porosity is again reduced by the compaction and cementation present in this rock. So when it comes to the primary porosity, it tends to be homogeneously distributed, whereas secondary pore spaces are formed after the rock is deposited and they are mostly non-homogeneous. That means when it comes to the secondary porosity, it is caused by the chemical reaction of a solution or any kind of physical forces like fracturing or forming of joints and compaction or any kind of chemical alteration. And next we go for the next parameter, specific yield. Specific yield is something very important for the groundwater studies mostly. The groundwater, the specific yield of a rock is generally defined as the ratio of the volume of water present in the rock yield by the gravity to its own volume. So neutron probes are usually used to determine this specific yield. If we take an example, the highest specific yield is found in the medium sand because it contains more of the uniform size of distribution. And lowest specific yield, let's say example, you take this as a sand, you have proper spacing and all. So this is having a good specific yield. But when you take this as non-porous, non-permeable, like silt and clay, they have a very low specific yield. So specific yield can be determined using the geophysical law. Then we go for the next parameter, that is the grain size. So you see the grains here, the grain size. The importance of the grain size is analyzing the hydrological characteristics of a rock can be seen from its effect on the porosity, permeability, and the specific yield. So till now we have discussed about the lithological parameters like the lithology and the resistivity, the porosity, permeability, grain size, and all. Now we will be going for the fluid parameters. Fluid parameters means the fluid that is being circulated inside the well, and also the fluid, for example, groundwater that is available in the well. So that both of them are fluids. So the second category we are discussing is about the movement of water and the borehole and also the formation of the groundwater. So the characteristics of the fluid in the borehole can be measured directly, but the data of the formation must be inferred from the logs also. So logs of conductivity and temperature of the fluid that is present inside the borehole can be related to the formation fluid characteristics. So if we go for the formation fluid characteristics, first we'll discuss about the fluid conductivity. So the fluid conductivity or the resistivity of the fluid in a borehole is one of the most important factor for the geophysical law. So see here if we have the brine and it is salt water, so you have some range in resistivity. So the fluid resistivity information depends on the conductivity of the fluid in the borehole and the rock. Then only we can interpret the log. Fluid resistivity information can also be used to calculate the fluid density for the correction of the water level data. Then we go for the next parameter in fluid formation fluid characteristic. It is fluid temperature. So the temperature, you see inlet temperature and outlet temperature will be different because the drilling fluid will be circulated and it cools off the drilling bit and it will take out all the rock samples. So the temperature is important factor. The temperature of the water in a drill hole may approach the temperature in the rock, without any hydraulic connection between the two. So when you are doing a temperature log can be used to determine the position of the curing cement behind the casing. Okay, and the temperature logs are also necessary to make correction for the water viscosity and also the specific conductance. Water from different aquifers generally differ in temperature, so that source of water and the movement in hole may be identified from the temperature logs. And then we'll go for the fluid movement. So the fluid movement is something like the direction and the velocity of the fluid moving within the borehole, and that can be measured by logging. And the other parameters that can be found by logging are the moisture content. The moisture content is the percentage of the moisture in unsaturated zone, and this is an important hydrologic factor that is related to the evapotranspiration and also the recharge, because based on the moisture content we can understand the well is being recharged or not. So if the moisture content is 0, that means the well is dry. The moisture content is 100, then the well will be recharged soon. So the measurement of the moisture changes may be done by the neutron logging, just to understand and to determine the specific yield. There are few geometric factors that are also considered before doing a well logging. See, usually what happens when we are drilling a hole or we are getting the information from the log, few disturbances takes place because of few geometric factors. So first is radius of investigation. The interpretation of well depends on the borehole radius. So you must understand the radius of the borehole also. So this is the drilling borehole, but you have different zones here: the flushed zone, the zone of transition, and the uninhabited zone. So the radius of investigation must be considered for all loggings. And then we go for the bed thickness. The spontaneous log, if you see here, see this is the self potential of the spontaneous or the SP log that is effective in determining the true position of the bed boundaries, because contacts are generally at the point of maximum inflection on the curve. Okay, and when it comes to the logging, there are few factors that affect the logging. So they are like the hole diameter, which we can measure through the caliper log. See the borehole diameter here. One of the most extraneous effect present on the logs is change in the diameter. Diameter changes can be divided into two types. That is change in the average hole diameter. So you see the change in the diameter of the borehole, and changes in the borehole rugosity. So differences in average hole diameter are generally due to change in the bit size or the drilling technique. So if you see here, the bore is some dia here, and here the diameter has changed, and here again the diameter has changed. Here the diameter has changed because of the change in the bit what the drillers used to do. And the borehole rugosity will change the values on the log, and the hole diameter measured with the caliper probes are essential for quantitative interpolation. So this is from the caliper log. You see here the value is constant, and here the bit size has changed, so it has gone to the side. So you'll understand the diameter changes in the borehole using a caliper log. Few holes drilled for groundwater have smooth walls. So if the formation is good, then you have a very neat cut of the well. Circulating drilling mud or water for a long time period can also affect the diameter. So the drilling techniques are major changes in lithology and are the common reasons for changing the average borehole diameter also. The deposition of the mud cake here. Decrease in the borehole diameter is less than the bit size and are due to the mud cake buildup. So the clay squeezes will generally continue to decrease the diameter until the hole is closed. The mud cake will squeeze and affect the response of some logging device also. The presence of mineral deposits may also decrease the hole diameter, or they also increase the casing. Any chances in the nature of thickness of the material between the logging sensor, that is the probe, and the rock will be affected by, because of the mud cake. So we should be very careful while finding the diameter of the borehole and the changes in the borehole by using a caliper log. And we'll go for the final thing, the effects of drilling on the logs. So drilling a borehole generally will move all the content in the well to the sides. So you see here the mud cake is pushing the water content or anything to the next zone and from to the other zone. So this place where the water content has moved by the mud cake is called as flushed zone. So this is we call it as flushed zone. And from the place where this is moved and it is went to the next location, that is zone of transitional annulus. And this is the place where the mud or the chemical didn't have any effect. This is called as uninnervated zone. So in a rotary drilling or manual drilling, the pressure of the drill bit and the drilling fluid and the pressure of the mud column will exceed the hydrostatic pressure, and the mud will infiltrate into the rock, and that we call it as flushed zone. And during this process, many of the particles suspended in the mud are filtered out and they form a mud cake. The immediate zone and the mud cake may introduce uncommon and undesirable factors in the log interpretation. So we are all about this part one. In the part two, we'll discuss more in detail about all the other parameters and proper well logging techniques that are being used and the instruments that are being used and the working of the instruments that are being used for the logging. Thank you.